Let's take a look at the Daily Leetcode question of 10th March. It's a video one. It's called as count of substring containing every vowel and k consonants too. We were given a string, word, and a non-negative integer k. We have to return total number of substring of word that contains every vowel a, e, I, o, and u at least once and exactly k consonants. So we are given a string word with these letters. We have to uh, return total number of substring of these alphabets that contains every vowel, right? And at least once. This is the consonant that we have to add in our string word, right? So here there is missing vowel u, so we can't make any substring here. So we'll return 0 here, right? In this, we have 5 vowels that we can put in a substring. So we'll output 1 here, right? So there is no need of a consonant. So we'll just return this again, right? In third example, we have to put in 1 consonant. So these are all the uh, string that we can make with 5 vowels and 1 consonant, right? So here Q is a consonant, right? Here Q is a consonant again, and others are vowels. Here also Q is a consonant, and other 5 are vowels. Constraint is 5 to 2 into 10 to the power 5, and word will only consist of lowercase English letters. So there cannot be any uppercase letters here. And k will be from 0 to word dot length minus 5.
We will take a look at the example. So our string word had these letters A, E, U, I, O, M, A, O, U, C, I, and E. So now we will write down our possible substring we can make from this. K is 1. We'll mark our indexes here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Firstly, we'll take a look at the first index here. Index. So first substring can be. So now we take 5 vowels and then 1 consonant. We are taking first consonant, first vowel A, then E, U, I, and O, and then we will take this consonant. So we can write down A, E, U, I, O, and M. So we got 5 vowels and 1 consonant. Now we can move to 6th index here, and this again we will carry from our first example or from our first substring. So again we will write down this again A, E, U, I, O, and M, and then we write down A here. So here we are repeating our A vowel. So we got 6 vowel and 1 consonant. We are already fulfilling the condition of 5 vowels, at least 5 vowels and 1 consonant. And then for third, we take O here. So when we write down A, E, U, I, O, M, A, and O, right? So now we get 7 vowels and 1 consonant. Then again we get U here. So we can write down A, E, U, I, O, M, A, O, and U here. So 8 vowel and 1 consonant. Now we went to our 9th index here. So can we write down this combination? A, E, U, I, O, M, A, U, and C. So now we get 4 vowel and 2 consonant O here. So this is not correct, so we can't take this combination here because there are two consonants. In the question, we can only put in one consonant here. This combination cannot exist. Then we just skip moving to our I and checking these two also. So this will also not happen because these will also have more than one consonant. Now we move to our first index here and again check this like we did with our zeros index. We write down index 1. Now we go to our first index and start making combinations E, U, I, O, M and A. So in this we can just put in this substring because we are fulfilling our 5 vowels and 1 consonant here. So we got E, U, I, O, M and A, and then we move to O here. So what we are getting now? E, U, I, O, M, A, and then we add O here. So we are getting 6 vowels and 1 consonant. And in third, we move to U here. So we get E, U, I, O, M, A, O, and U. So 7 vowels and 1 consonant here. Ninth index now we get E, U, I, O, M, A, O, U, and C. So now we are getting 7 vowels again and 2 consonant here. So this is not correct. We can't take this combination because there are more than 1 consonant here. So next combination we will just skip here from moving to I and E here because these will also have more than 1 consonant here. Now we move to our index 2 here and again check just like before. Now we try to make 5 vowels and 1 consonant combination again. So we try with U, I, O, M, A, right? So now we see that we cannot make any combination with 5 vowels because our last vowels is here at the end, and if we take this full substring like this, we will be getting more than 1 consonant here. Like M will be there in the substring, I will be there, right? So we can't take this substring, so we'll skip this index 2, right, and move to third index. So now we see that again we are getting more than 1 consonant here. So 5 vowels are there, but the consonant are more than 1. So we'll also skip this index 3 here, right? And we move to our fourth index. Now again the same thing will happen. This will also have more than 1 consonant, M and C. We will also skip this and move to fifth index. Again same thing, more than 1 consonant. And now we write down our combination on sixth index. So index 6 will be A, O, U, C, and I, E. So we write down A, O, U, C, I, and E. Write down 5 vowels and 1 consonant here. So we reached our end alphabet. So there will be only one possibility from index 6. So we put our combinations 1, 2, 3, and 4, 5, 6, 7, and 8. So we will output 8 here. Now again we see the example. Now we will approach this with the sliding window. A, E, U, I, O, and A, O, U, C, I, and E. So we mark the indexes here 0, 1, 2, 3, 4, first valid window was from 0 to 5. So we'll count the number of letters here: 1, 2, 3, 4, 5, and 6 for index 1. This will be our expansion window. To simply get the number of possible substring from index 1, we can simply subtract the total number of letters minus the index of our first substring. So 12 minus 5 will be 7. So this will be expansion window. Now we find out the possibility of shrinking windows. From index 1 to last index. For index 2, what we can do, we'll simply start from here till our 6th index. Now we will be again finding the number of substring here. So 12 minus 6, that is 6. So for index 3, we will take substring from U to E total. So there will be only one substring here. For index 4 and 5, no substring will be there because consonant will repeat, and index 6 will also have only one substring. Now we will check for the repeated consonants here. So in the index 1 we were getting these repeated consonants. So total 3 substring will be removed here. We will get 4 possibilities, and for our index 2, same, these 3 will be repeated. So again we take 3 possibilities here. These also have 2 consonant here possibility, and now take all the sum of the possibilities here as 4 plus 3 plus 1, that is 8.
Let's take a look at the code part. Firstly, we'll define three functions here: public, boolean is consonant, then all vowels present in frequency, and then at last uh, at least one consonant. For a count of substring, we'll simply return at least one consonant, k, and word. Word is at least k plus 1. K plus 1 is when there are more than one consonant. This is the operation where we need to find the number of possible substring for a given index. So here we'll return when character is not equals a. We'll simply copy this for other vowels as well. A, E, I, O, and U. For all vowels present, you simply return a combination of variables, a combination of vowels like A minus A, E minus A, I minus A, O minus A, U minus A, like this. A minus A is greater than 0. A, E, I, O, I think this will be now we'll uh, define count 0 in current consonant as 0 as well, and frequency will be nearly 26 letters of alphabets in N. As they are all small, so we will only take 26 here. Words dot then now we define our left and right pointers. And right is 0, right is 0, right plus plus. Okay. Is K and all vowels present for the frequency. Count will be incremented by n minus right. Then pair. Now we take a different name here. We just take uh, correct here. This equals words dot caret. Now it will be left, and after this it will be right. It will be right. Yes. Current consonant there will be one more if condition here. If is consonant is ch and consonant will be incremented here. Now we update our frequency, character minus the character. It will also be incremented. Now if this consonant is we pass here, direct here. Now we'll decrement. Firstly we incremented, now we'll decrement it. And we'll update our frequency with direct minus a. This will be decremented. Then we'll increase our f plus plus and return our count. Illegal sort of expression. Okay, this will be frequency. I don't find symbol at least. Write operand type for binary operator at line 3. This will be closed. Okay, so you can now